Welcome back, guys. We are going to start the next session on shift left with Ragavan, Principal Test Automation Engineer from Expedia. Before we start, quick reminder for those of you who weren't here, you can add your questions to the chat, which you can find on the right-hand panel under stage. Just drop them in, and as and when they come up, I'll be going through them, and at the end, we'll have 10 to 15 minutes where we can do Q&A. Now, without further ado, I am pleased to introduce you to Ragavan. Ragavan comes in with a wealth of experience spanning 19 years in test management, automation frameworks, testing of websites, services, network management, and mobile applications. In his current role, he enjoys the freedom he gets to evaluate and implement new solutions, loves technology and the challenges that comes with it. And in his spare time, he spends time fixing bugs for open source tools, Selenium, Test Load Balancer, Cucumber, SeleniumGridScaler, and SimLauncher. Ragavan also mentors and builds champions' rights and speaks at events. Today, Ragavan will be talking about shift left. His session is all about the why we should move to shift left. Simply put, when you merge your code changes, the code should be production ready. He'll take us through how to automate the process to ultimately avoid the costs of production incidents. Ragavan, I'll let you get right into it. Over to you.
Thank you. All right. Can you see my screen quickly?
Yep.
Okay. Thank you very much, Jay. My name is Ragavan, and today my topic is going to be shift left and pre-commit pipeline for PR validation. So basically, what is shift left, right? If you take any CI/CD pipeline, the things that you do before you merge your code to your main pipeline, you previously called master pipeline or master branch. Whatever you do before that, you can call the left side of the pipeline, and whatever you do after that can be called like progressively to the right side of the pipeline all the way to production. So the focus of the talk is going to be we are used to doing things to the right side, and how can we benefit from doing things to the left side of the pipeline, which is close to the code. I work in Expedia. I'm a principal software engineer, and yeah, let's go into the topic. So what are the key ingredients of a good CI/CD pipeline? One, fail often, which means run tests frequently. Two is test relevance. You focus on micro tests, so you don't have to test like everything under the sun. Three, test fast. So which means you can run your test concurrently, or you should run your test concurrently so that you can test fast. And the fourth one is shift left. Whatever you test close to the code, not towards the release. And the final one is fail fast, which means whenever you run something, but make sure you run the critical one first, because when they fail, then you can stop immediately. And no faster is something I added because all of these are saying fail fast and fail often. But if you know they failed after 1 or 2 hours, then there's no point in them calling them fail often and fail fast. You should know them immediately. So why I'm going to talk about what are the problems faced that I'm trying to address here. Why shift left is important. These are numbers I took from Gartner and very important sites. Like over 600 million hours a year is spent on debugging code in North America alone. This equates to around USD 61 billion in salary cost alone. Fixing a bug takes 30 times longer than writing a code, which means you have to spend more time when things started failing to the right side of the pipeline, in your master branch, in your master pipeline, or in production. And 75% of developers' time is spent on debugging, for example. Especially think about when something goes in production, something goes down, then lots of people have to be involved. And besides the impact on revenue, but lots of people need to get involved in fixing as well. Again, I'm looking at through another lens why shift left is important, why you have to test close to the code. Imagine if 1 minute production outage is causing you around $20,000 USD, and on average, if it takes 1 hour to restore a production incident, then easily you could lose $1 million, close to $1 million in an hour. And this 1 hour could be happening every day, or it could be happening every week, every month, every year, across the year. We don't know when this happened. So only way to make sure that this doesn't happen is when you make any change and merge and you merge to the main, the change has to be production ready. It has to. You should have the confidence that this change can go to the production right now, right? And also, it's not only the money, but also you're going to have unhappy customers when things are failing in production. So this is how a normal pipeline looks like. You commit to main, and you run your sequence of steps of unit integration, functional, performance, security, and then you have that's called pre-prod, and then you have canary and production. So this bar chart is actually from NIST, which is National Institute of Standard and Technology, which is part of U.S. government's Department of Commerce. You could see that the cost of fixing things as they happen to the right side of the pipeline, it costs you more progressively, right? So it's a no-brainer that it's cheaper to do things to the left side of the pipeline than to the right. And my objective of this presentation is to change that paradigm shift and show you how we can do that and why you have to do that. One of the pain point of the normal pipeline, even though, for example, Spinnaker is a CI/CD open source tool, it allows you to run your pipeline either multiple instances of the pipeline at the same time or just one. But most of the companies, I would believe that they want to run the master pipeline only one instance at a time, which means walking on the road, only one person can walk on the road. And the second person can walk on the road, on the same road, only after the first person reached its destination. And that's how a typical CI/CD pipeline goes, the main pipeline. But what are the consequences? Every other people who are waiting to check in or merge their pull request have to wait, because as soon as you merge, your pipeline is going to be triggered, and it's going to wait. So this is another pain point of why the current approach is slow of trying to test everything to the right side of the pipeline. So I asked an engineer, what is the normal developer cycle looks like? So after creating a pull request, how much time it takes to get feedback on your pull request? Like how much time you have to wait before you know if your change has caused any outage, either a pre-prod or in production. So you wait for code review after your PR is ready, which normally more than one person. You wait in queue for the PR to be merged, because you only want the master pipeline runs only once, once at a time, and wait when some PR in front of yours is merged but failed in the pipeline. You wait for it to go through the pipeline again, and wait for high priority PRs like hotfix. So this could be few hours to days before you can actually context switch and start focusing on a different story, right? And instead, what if I say you can take your change from your branch, deploy it to a temporary stack in Kubernetes within 10 minutes, run your test, whatever test you want to run against a particular customized URL, get feedback in less than 30 minutes, and destroy the stack. And every one of your engineers in your team can do this concurrently. How cool, how good it is, right? So another a different perspective I want to give, what is the value add this is bringing? These are not random numbers. These are sample numbers of number of pull requests of 5 different applications throughout one particular year. I think it's close to 7,000 pull requests. Imagine if we can save 1 hour per pull request in productivity, how much time we could save. Roughly, that's equal to 5 work years, which means you're getting 5 extra resources for free just by increasing the productivity. It's a different way to look at when you have statistics which won't lie, right? So shift left is also going to increase your productivity, and that's what I'm coming to say by showing this number. So before you merge to main, this is how it looks like. You branch out, you commit, you create pull request, review, discuss, merge, it goes to main, right? And multiple sequence of this will happen by different engineers in the team. And this is how your normal pipeline looks like, where after your pull request is committed to the main or merged to the main, then you run your build, which has static and unit tests and contract testing and code coverage. Then you deploy, then you run all your functional tests or load tests and A/B tests and security. Then you release your version, canary, deploy to production and production monitoring. So as you can see that when things started failing to the right, it costs you more. And this is the overall big picture. You have a pre-commit pipeline and then your regular pipeline. The idea of the shift left is to give or create a solution or an infrastructure that everyone can use, where they can run everything here over here, which means you can take a change and run everything that you would normally run after you merge your pull request master, even before you do that. So when you actually merge here, your change is production ready. Of course, it could fail after you merge due to numerous reasons, but the overall idea is we are taking every step to reduce the chance of it failing pre-prod or in production. And another benefit of having a shift left of a pre-check-in pipeline is when you use EKS, Kubernetes and Istio, you can deploy multiple instances of same application and run at the same time. So if, for example, you have app X, and you can actually run multiple instances of the same thing within the Kubernetes stack, which means many people are working on different pull requests, and they will be running their own instance, which are associated with their own pull requests. Multiple EBS can be deployed concurrently as well. So it's unlike your main pipeline where you can only run one instance. Here, there's no limit. So nobody has to wait, right? Changes to PR can be redeployed. For example, if you want to deploy every commit to your branch, because a branch can have many commits, more than one, then you can continuously redeploy and overwrite the same stack with the new changes, and you continue to test. And this is a visual representation of what I just said, where you can see that you branch out, you build, and you deploy tests concurrently for numerous branches. This is the overall flow of the shift left. So as you can see here, this is the branching out, and when you branch out, you can commit many times. As you can see, there are many arrows going from this. Each circle is a commit. So basically, you can configure in such a way, because Git has so many listeners or events for different actions. You can say for every commit, take the Git hash and deploy it. Or you can say every time a pull request is open, deploy it. Or every time someone commented on a pull request, deploy it, or for a particular word. Or when a pull request is reopened, deploy it. So the point is, by listening to the GitHub events, you could take certain actions and deploy it. And by using Kubernetes and Istio, you can have a particular URL just for your own change. So imagine if this is your app name, you can have app name -pr100, or you can have the app name pr100 as part of your domain name itself, which means you have a URL that you can hit that's exclusively carrying your change, right? And once you get it, you can actually run any of your tests that you want, Lighthouse or accessibility or regression or performance or anything. Once you're happy, you merge it. When you merge and your pull request is closed, you can trigger an action, say, go and delete the stack, because once the pull request is gone, you no longer need to run the stack, right? And this can continuously go on forever. And so that's the whole idea of this shift left pipeline. Again, you might think, like, is it an overkill that you want to run everything for every commit and everything? It's not like that. You can pick and choose what you want to run, but the overall idea is to give a platform, give a solution so that based on your judgments, if you think that, oh, okay, I'm making a change that's very much performance intensive or performance impacting, I'm going to make sure at least I run performance and plus a couple of other things. Or I'm going to make sure that this is an accessibility change. I'm going to make sure I'm running accessibility plus other things. So it's not like you have to run everything all the time, but at least make sure that you make your own judgment, because you cannot test everything all the time. So it is just a guideline. So as I said before in one of the slides, so deploy stack, you listen to events. One of them could be PR create event, PR commit event, PR reopen event, and then you trigger. I'll talk about how you deploy, and those events you can actually deploy that. Also, when you destroy is when you listen to PR close event, and you can destroy the stack. So how you can create this pipeline? For example, there are many ways you could create this pre-check-in pipeline. One is you can use the Git hooks and the Jenkins plugin and make sure that they interact with each other. The image you are seeing here is for this particular Git repo. It is mandating that every commit following job need to run and make sure they are green. Otherwise, it will not allow you to merge the pull request. And here you're seeing a Git a Jenkins plugin, a Git Jenkins plugin, which is listening to certain phrase in a trigger phrase in your PR comments and looking for skipping certain build phrases and running every few minutes to make sure that is there any event that I need to respond. And this will be the starting point, and it can trigger a deployment job, it can trigger an automated job, so it can go on. So this could be the trigger point where the subsequent action can follow. So this is one approach for pre-check-in. The second approach is GitHub Actions workflow for PR validation. GitHub Actions is a new feature in GitHub where it helps you automate tasks within software development cycle. GitHub Actions are event-driven, meaning that you can run a series of commands after a specified event has occurred. For example, every time someone creates a pull request for a repository, you can automatically run a command that executes a software testing script. The thing I like about GitHub Actions is when we say shift left, when we say that everything has to be close to the code, I don't want to context switch to a different tool to see how my deployment is going on, how my test run is going on. I want to see right there in my pull request, right? Because then you don't have to context switch, you don't have to go to different tools, another Jenkins job or Spinnaker or anything. So what I like is GitHub Actions is, you need to have a YAML file under .github in your repository under .github/workflow. And every YAML file, any YAML file, it can have a set of instructions based on the GitHub action syntax. For example, it can have triggers when something should happen on pull request, on issue command, and it could have what should happen when when some event happen. In this case, you can define many jobs, and each job is a set of steps. For example, you could build, you could deploy, you could test. And when I say test, it could be something similarly what you run normally in Jenkins. It could be a part of a script and you are calling it, right? And you might think, where is going to run? So you can actually say, I'll show you a particular thing here. So here you say it's run on. You can say run it on Ubuntu latest, and GitHub will make sure that it runs on a Ubuntu box. You can also run some similar things on your own host. They call it self-hosted in your infrastructure. So this is a sample GitHub Actions. For example, it's listening on any push event to branch master or pull request event branch master, which is main, and it has a job. A job has one step, and basically what it is saying is whatever I'm mentioning here, run it on Ubuntu latest, and at the same time you check out Node.js, check out the repository and install Node.js version something, and you install and run test and you run the build. So this is a very simple example. And another example here is pull request assigned, open, synchronous, and run it on a branch, run it on any branch when you leave it empty on one of these boxes, one of these label boxes. Or here you can see the tag where you're asking to run only if the tag matches any of the syntax here. Another example here is pull request type open. Only run this when a pull request is opened, or when issue comment is created, and you say run it on Ubuntu latest. And basically what it is saying is whenever you see a trigger command which is deploy, then create a rocket icon to the comment. Right. So this is an example. Basically, GitHub also has a marketplace where you can go and look at what people have already created and then actually use them, like how it is being used here. This is created by someone called Mr. Khan, and I'm using it here. So you can actually go and you reuse what other people have already created and build your chain of pipelines as in your code itself. As this is an example how it will look. But the actual workflow is, this is what I like, because you can actually see everything on your GitHub UI itself. So for example, I want to see my integration unit test. I can click and see, and even look at the log, what it, how it ran, and etc. So you can have your chain of jobs here, for example, which takes your pull request, the Git hash, deploy it, run UA automation or any sets of automation. That can be one flow where you define a big set of jobs, whether you can configure them to run concurrently or sequentially, make sure one job depends on other. For example, a test job will depend on deploy job, for example, right? So this is very powerful. It's not a very old feature. It's very new. I would say 2019, I think it was released. But this is a perfect tool if you want to actually do shift left. As I said, you don't have to go anywhere. Everything is right in your code. Everything is part of your code. That's the biggest advantage. Of course, there's other tools like Spinnaker as well, where you can do the branch-based deployment, because it allows you to trigger a pipeline not just after committing to main, but also by other means, like you can trigger based on committing to branch and whatnot in Spinnaker. Another point I want to make sure is as we are all moving towards microservice, sometimes I hear pain points like, if I want to test a microservice and micro front end, then I have to deploy both to my test environment and make sure they are working fine. You don't have to, because otherwise it beats the purpose of why we have microservice and front end. You have to see how you can decouple them and release them independently. Because releasing them independently and making them independent is part and parcel of if you want to be successful in shift left. For example, you could use consumer-driven contract provided by Pact to create a contract between consumers and providers, and make sure that they don't actually need to talk to real services, but they just need to respect a contract between them, and they become independent of each other, and you can release them without them actually breaking each other itself. And also stubbing and mocking. So these are important things that you have to be following if you want to have a successful shift left. I want to talk about return on investment, because any tool, any solution you develop, you don't want to develop because it's cool or because you think it's nice. Definitely, we need to show what your benefit, what your organization is benefiting, what your team is benefiting, what your company is benefiting with this initiative, right? For example, so you should be able to measure what you're doing is actually providing value to your organization, right? You should be able to measure it, like really measure it. Of course, not everything you can measure, but if you can measure, you should do it. So one metric I would use is increased productivity, hence overall sprint velocity. How shift left is increasing productivity? So based on real world survey, I'm saying number of hours saved for a developer is 2 hours per pull request, because he or she need not wait for lots of people, need not wait in queue and things like that. You can easily context switch. So it's 2 hours a day. And also, they don't need to wait when things break in the main pipeline, because that's what we are trying to avoid. With shift left, anything fails, they know they might be the primary reason why it failed and immediately fix it, because that's the only change in the temporary stack. Number of hours saved for all code reviewers. Normally, a pull request can have 1 or 2 code reviewers, and sometimes they even download and try to run unit tests just to be safe. But now, everything what a main pipeline would do will be already done in the shift left itself. So, when you see your job, when you see your shift left test reports and everything in your PR itself, then they're going to have lots of confidence, and they're going to have to actually spend less time in reviewing code. So 45 minutes per pull request in time saved for at least 1 to 3 reviewers. Number of hours saved for the rest of the team, that because they don't have to wait. They don't have to wait when something breaks in the main pipeline. They don't have to wait in the queue. They can get quick feedback. So all of these together, with this, if 5 teams with 7,000 pull requests per year, it saves around 31,150 hours totally, which means you're saving around 14 working years. That's like 2 different teams, or your productivity has increased by like 14 times, right? Or another way you're looking at is you can actually create 2 more teams out of this because of increase in productivity. Return on investment, other metrics are, for example, reduction in production incident. Obviously, you should see reduction in production incident, because now that's exactly what you're trying to do, and reduction in defect raised against an app, and also increase in overall sprint velocity. Of course, it'll be natural to see probably the production incidents are not reducing at all. But so, all you have to see is go back and see what you're doing wrong in shift left. This incident type you're seeing, for example, if it is a production performance incident, are you doing any performance testing as part of your shift left? If it is something related to stress or load, are you doing load testing or anything in your shift left? It is continuous learning. It's not like magically suddenly your production incident are going to drop down, but you have to keep making sure that if it is not going down, but you go back and see what you're not doing in shift left that you're supposed to do. And obviously, as for the previous slide, you should see a increase in sprint velocity as well. Another important thing is cost optimization. As I said, the infrastructure cost of shift left, as we are trying to reduce the loss of revenue that's because of issues happening in production or pre-production, should be fraction of what is being saved. You don't want to spend more money to save less, right? So how can you further optimize and make sure that you're spending a fraction of the amount that you're saving? Ignore certain types of files from triggering your shift left pipeline. So, for example, changes to MD files, so changes to a certain file that that is never going to go to production. Use spot instance instead of reserved or on-demand instance. GitHub has a feature called draft pull request. For example, if your shift left pipeline deploy for whenever PR is created, you can create a draft pull request if your pull request is not even close to ready, so that you don't unnecessarily deploy things that are useless, right? And waste unnecessary CPU and memory time in AWS resource, because the main reason we are all using cloud is to make sure that we use it only when it's necessary and keep on optimizing. And you can also destroy your stack running for more than X hours. A lifetime of a particular pull request could be from few days to say like 5-6 days. For example, during weekend you don't need it, so you can actually have a Reaper task running to kill any stacks running for more than X hours, and that they will be gone. Or you could say that I want to have a feature where if I say deploy, the pull request should deploy on demand. So they don't just lying there for no reason. And also having the ability to, as I mentioned, based on a comment you deploy. You can say like why there is canaries there. Why can't we just use that? Canary is a gatekeeper. It cannot prevent issues. It can only reduce the impact. With Canary, you will still have unhappy customers. So Canary is a good addition to whatever Shift Left is trying to do. And why not laptop? Why can't you do it? Laptop is not scalable, right? Even though if you have Mac Pro with 32 GB memory, it fits enough only for running unit tests and not powerful enough to run various different tests. Of course, you can run even UI tests, but do you want to wait like 20 minutes looking at your screen, browsers popping up and down? Yeah. Or even if you're running in headless mode, it is going to take more time, unless you're running in parallel, and which, again, you are limited by number of CPUs and whatnot. So one of the best practice I would say is, when I was presenting this, one of the engineers asked, isn't it going to make developers lazy, because now everything is happening on fully automated from unit tests to everything for every commit? So I think that's a good question. So that's what I make sure that the shift left has to start after unit test is successfully completed, so that if unit test itself fails, we save unnecessary cycle of resources deploying and failing there. So and also it should be easy to onboard to teams. So that's the whole point of shift left. You need to balance the good and look at both sides, and so that it is not completely totally dependent. At the same time, you can have the way you construct your, for example, workflow to have first unit test run and then trigger the pipeline. That will make sure that you're not making people lazy, at the same time achieving what you intend to do. And these are some of the tools: Spinnaker, plugin to GitHooks and debug workflows, and that's all I have. Yeah.
Hey Ragavan, thanks for taking us through your playbook. I think very instructive. We have a lot of questions lined up. Folks, we will be running another poll. You can access that under stage next to chat. If you'd like to help with your test setup, please answer that now. We'll be getting right into questions. We have a lot of questions on your pipeline implementation. Let's start off over there. So how long does your test flow take to run currently for each PR? Do you run only certain tests on PRs on certain parts of the application, or do you run all tests?
So currently the decision is left to the team, because I built this as a solution. But normally I know a default people will run Lighthouse tests, sometimes Cypress, sometimes some teams use Nitro.js and Selenium combined test, and very few people run a visual regression. But the default I see, at least for micro frontend app, is Lighthouse, some form of UI automation test, either Cypress or Selenium-based test.
We have a question asking for your advice. So our biggest problem with several branches and PRs from the same repo is merge conflicts. Do you run into a lot of merge conflicts? And if so, how do you deal with them?
Definitely, it is something is going to be always happening when you have many people working on that. I think one way, personally, I would suggest is keep rebasing with your master, so that whenever you're working, and normally it's normal for PRs to take probably for 3-4 days or probably 5 days. So every time you work, make sure that you're rebasing instead of just working on whatever you just created. So when you try to merge, you're in a better shape. And even if there is conflict, it will be easy to manage than not rebasing at all.
With multiple pre-merge applications deployed, how do you handle data-related dependencies? How do you guarantee that a database is set up and you have the correct data set for your tests?
I don't know if the question is for the app's dependency on external services or the test dependency on data. Can you? I can answer both. So if the question is about how do you make sure that the app is talking to different services, so we deploy to Kubernetes and we make sure that if the micro frontend, for example, need to talk to some other service or some other backend service, then that is reachable. But also we are trying, for example, some form of stubbing or deploy in offline mode or stub mode, so that you are less dependent on real services. And if it is UI, you're only interested in UI. You don't mind about where the things is coming from, whether it's coming from live or it's from your stub. Yeah.
Awesome. There's a question about shifting left even further to the designs of the UI and the architecture. What do you think about this?
Definitely, yes. I think you can solve lots of issues even at design phase, even when you're talking about features and things like that. Sometimes when you go to sometimes too much, probably it might become like waterfall. But I totally agree with that point. You can further go to the very left and try to reduce unnecessary problem that could happen probably 6 months down the line. So definitely even further you can go shift towards the left at design phase if it's a very complicated application. The more time you spend on the time, less problem you're going to go get to the right side.
Got it. So the approach that you showed us, pre-PR, is this to reduce the time of a code review done by a developer, or are we talking about tests on commit and reducing that time?
So the metrics I showed you are multiple benefits. The main benefit is to reduce any failures to the right side of the pipeline, so we don't spend unnecessary time fixing them, whether it's pre-prod or production. But the byproduct of this this approach is developers, reviewers, and the whole team, for some reason or other, has to wait less amount of time if you don't have shift left. Because in the master pipeline or in the main pipeline, many teams probably disagree with me. I don't if you are not following that one pipeline instance at a time approach. You have to wait. And then also the problem is when something happens in your main pipeline, then everyone has to get involved, because you don't know whose change has created the failure in test, or what deployment or something failed. Multiple people need to get involved. But if something fails in your shift left, in your own pipeline for your own change, you know that you are the person with only one change, and so you can easily debug, or you can even do some elimination. So it's not only just for saving time. That's in my opinion, that's a byproduct of shift left. But the overall goal is to reduce problem happening to the right side of the pipeline.
How do you enable the PR author to know the status of pre-commit testing? From the moment the PR is created, building the app, deploying Kubernetes, running the tests, so that they can rerun the whole flow.
So I understand, how do you let the PR author know all these status? So I think Git allows you to update your pull request with different status message. In our case, you can actually see where, what is the status of the deployment job if it's green. And also it will actually show you the URL that you're supposed to click, and it will take you to your application where it is deployed, with the PR number and everything, so you can straight away start interacting with it. besides you automating, if you want to manually interact with it and see how it looks. So it is based on using very much GitHub features.
Could you expand a bit more on talk a little bit more about the micro front end that you talked about?
So most of the beta customers, alpha customers that we have onboarded are micro front end apps, so that they are single page React-based applications or PWA-based applications. So for them, you can just deploy them, and it's just single page. Make sure their page is fine, and continuously reiterate. So that is what most of my examples are right now. I don't know if you're asking about the pact of contract-based testing. That's like a different story where you don't want to couple your micro front end with microservices, and you have to deploy both to an environment if you want to test and things like that. Because the whole point you have two different microservices is because you should be able to release them independently. At the same time, they don't break each other. At least the provider, in this case, a service is a provider and the micro front end is a consumer. And you can use contract-based testing, a tool like Pact, to make sure that they respect each other, in the sense the provider respects what is supposed to give to the consumer using a Pact file, and you still can release them independently, and you don't need to actually depend on each other like an actual service. You can always, so it's by using mocking and stuffing.
Would you recommend Pact to smaller teams, say with 20 devs, especially considering the associated costs of training, running and maintaining the infrastructure?
If you have microservice and micro front ends, I would say please use it. I took like a week to understand. I created my own Pact broker, and it's a super easy, especially if you have many versions of your provider and many versions of consumer, and you can actually say, can I deploy and give a version of your consumer and give a version of provider. It'll actually tell you based on the metrics of already tested metrics, saying, oh yeah, you can. Whatever you're going to deploy will work with the provider that's currently running or currently you tested. So it's super easy. It's not super hard. And especially on the provider side, you don't have to write any tests. It'll just run everything based on the contract file, the YAML file that the whole request response is. And you don't actually have to write any tests at all from the provider side. It's super easy. Yeah, I would totally recommend, yes.
There were a few questions on the share of ownership between test and dev teams. How should that separation of responsibility look like, in your opinion?
Expedia, I would say we are moving towards an engineering team. The whole team is responsible for everything. So I'm sure different organizations are taking different approach. Even not every team is following the exact same model, but that's where the direction is moving towards. If you create a feature, then you are responsible for writing tests and make sure that everything is working until it's in production, automation and everything. But we do have a automation infrastructure team, for example, myself, that we create tools and infrastructure for everyone to use it, so that someone is wearing a quality hat and making sure that, okay, these etc. Good practices are followed, for example.
Awesome. So at Expedia, what is that share of ownership look like?
So for example, if you take a really mature team, there is no automation engineers, for example. It's all done by the engineers, the developers. So there's no shared ownership at all, is what I'm saying. Most of the cases, but there might be teams who are trying to get matured and going to that place, but it is happening. For example, if I take 5 years ago, yes, there was test team and there was dev team, and they're responsible for writing automation and they're responsible for writing code and things like that. But this has changed a lot. So there is no very much a shared responsibility. It's what everyone's responsibility, whoever is writing the code. Yeah.
Awesome. Final question. So what did that evolution look like, say, like from 5 years ago to now, from getting a team to the level of maturity that you're talking about, where engineers take, responsibility to do the testing?
So once upon a time, you had something like one QA org and then developer org. Then you had a team where a QA pod is there and the dev pod, both reporting to different people. Then you had an engineering team. Everyone is reporting to the same engineering manager. There's no like QA manager, engineering manager. Now you have engineering manager, but there is no mixture of test dev, but there's just engineers, software engineers, making sure. It means they could have been previously test automation engineers or something like that, but they're all software engineers, and they will be writing both code and automation together. So that's the part. I hope I explained it correctly. Yeah.
Awesome. So we are out of time for questions. We've covered most of them. There are a few that we haven't, which Ragavan, will be great if you can, if we can get those answered. I'll ping them to you over chat.
Thank you.
It was a pleasure having you. Thanks for putting together a very informative session. Sharing your insights, how you do it at Expedia. Yeah, guys, let's give it up to Ragavan for an awesome session.
Thanks for the organizing team. I think it's fantastic. I got my T-shirt on time, and I just literally got 1 hour ago. So thank you very much. Thank you.
Awesome.
Thank you, Jay.
Awesome having you. Thanks, Ragavan.